4.3, we're going to do complements and conditional probability, so it's kind of a review, but we'll go through it nonetheless. Part 1, complements is the probability of at least 1. So whenever you hear that probability of at least 1, you should be thinking to yourself, complement. So I would find nothing and then subtract it from 1, right? Because that would give me at least 1, right? Okay. So let's go ahead and jump right into the example here. Example, accidental iPad damage. A study by Square Trade found that Square Trade, is that still around?
I don't think so.
There was a time when that was pretty big, Square Trade.
Huh?
What is it? What'd you say?
Square Trade?
Oh, I don't know what that is.
You don't know what it is? Okay, anyway, found that 6% of damaged iPads were damaged by bags or backpacks. If 20 damaged iPads were randomly selected, find the probability of getting at least one that was damaged by a bag or backpack. Okay? So, in other words, how are we going to find this? How are we going to find this? So we have 20 tries. We're going to find, we get 20 bags or backpacks, right? Backpacks. Okay, so how do I find the possibility none of them is from this, right? Is that what we're going to do? Okay, so if we found since the probability is 6% they were damaged, 6% would be damaged by iPads. The first one would have to be not damaged by a bag or backpack. What's the probability of that? It's 1 minus 0.006, right? Because 6% are damaged from the bags or backpacks, correct? So the probability of it not happening that way is this, right? So the first one will be this, and the second one would have to be the same, and the third one would be the same and the same. In other words, you would have to have 20 of these that are not damaged by the backpack, correct? If every single one of them were not damaged by the backpack. Do we get this? Do you understand where we're at, what we're doing here? Okay? So there's 20 of them, and every one of them cannot be damaged by bag or backpack. Right? So this is the probability that every single one of the 20 of them are not damaged by the backpack. But what are they asking for? They're asking for what is the possibility that at least one of them were damaged, right? Which means that it is the complement of that. Correct? Okay? So it's a roundabout logic, but you're right. Otherwise, if you didn't do it this way, how would you do this? You would have to find the probability that one of them was damaged by the bag or backpack. Then you'd have to go all the way through and find out what's the probability of 2 of them were damaged by a backpack. Then 3, 4, so on and so forth, all the way through 20, correct? And then add those all together, right? So instead of doing it laboriously that way, we're just going to do it this way. Does that make sense? And as if you do this, you're going to find that this is going to be 0.71. 0.71. Okay? So that's how you use the complement thing. Okay, now let's go to the conditional probabilities. Okay, there's a definition there, the orange one. Santos, read that for us.
Conditional probability of an event is a probability obtained with the additional information that some other event has already occurred.
Correct. So the notation underneath that says that PV given that A has occurred, right? So this is the probability of B happening given that A has occurred. And when do we use this? We use this in the multiplication rule, correct? When we're doing the multiplication rule? Because we had 2 rules, right? We had the addition rule and we had the multiplication rule, right? The addition rule went like P of A or B, A or B was equal to the probability of A plus probability of B minus A and B. This was the addition rule. And then the multiplication rule was that probability of A happening is the probability of A and B divided by, no, wait a minute. Where's this at? P A is N B, probability of B happening. Okay? This was the multiplication rule. Right? Multiplication rule. Okay. So those is that. So this is what the probability of A happening given that B has already happened, right? And that is the same as the probability of A happening and B happening divided by the probability of B happening. Okay? All right. An easy way to remember this is that if I go ahead and multiply this over to both sides, I get this, right? And you can kind of, it's not that this is the way, kind of thinking that these two cancel out and you get P of A. Okay, all right, that's how I remember it. Okay. So letting you know. So, that is the multiplication rule. Okay, so let's see if we can use this. Example number 2. Refer to table 4-1 on the next page to find the following. A, if 555 test subjects were randomly selected, find the probability that the subject had a positive test result given that the subject actually uses drugs. Okay? So let's flip the page. There's a table like the table that we're doing. So it's the given that there was a, given that he uses drugs, right? Given that he uses drugs, which means that you're using what? We're using the row or a column there? It's the row, right? Which one is it? Subject uses drugs, the top row, right? So there's 50 of them, and what is the probability that you get a positive test result? So it would be 45 over 55, correct? Okay. So this is logically how you would do this. 45 over 50, I'm sorry. 45 over 50, correct? Okay. So, but if you went by the definition here, okay, what is the probability that you had a positive test result and you used drugs out of the 555? It's 45, right? Shows it's 45. So this would be, top would be 45 over 555, correct? Whereas B is what? What is that? That's the probability that you use drugs, correct? So what is that probability? 50 over 555. So this would be, in the strictest sense, this is how you would use the multiplication. And now from here, you would multiply 5, 5, 5, top and bottom, correct? And these two would cancel out, these two would cancel out. You end up with 45 over 50, which is what you found through your head anyway, right? Okay, so this is how you would actually use the multiplication rule. Okay, so you are using the multiplication rule in your head when you just say, well, it's 45 over 50, okay? When you're reading off that top row, okay? So that's that, and there's confusion of the inverse. Whoa, what's that? Let's look at example number 3. Consider these events. It is dark outdoors. It is midnight. So, in the following, we conveniently ignore the Alaskan winter. Okay, why are we ignoring the Alaskan winter?
Because it's always dark. Or no, it's always dark.
Because it's always not dark, right? Okay, all right. Okay, so in the following, what's probably D given M? So what is the probability that is dark outdoors given that it's midnight? It happens all the time, right? If you ignore the Alaskan one, right? So what's the other one? Probability of it's midnight when it's dark outside.
Zero.
It says 0. Why is it 0? It is dark when it's midnight.
But it's not midnight when it turns dark.
Because most of the time it's not exactly midnight, correct? Right? Because midnight happens that one split, absolute, that one little split second, right? Versus all the time when it's dark. So it's 0. You understand why it's 0? It's 1 over a billion of those. Billion seconds or whatever. I don't know how many, whatever it is, right? Okay? So yeah. In other words, rarely is it that P of A given B would be equal to P B given A. Okay? All right? Okay, so we'll stop right here today. We'll do Bayes' theorem tomorrow. So today your homework is 5 through 16. 5 through 16. As you need to.
$6.40 on the English. What? That's all funny. It's all funny. English was easy.
It's actually, it's like a county version. Number 5, the one where you just do like rules on the 10th page.
Don't break your nose. You can literally. I can't see. I'd like to say it's quick and fast. No, I'll just say that it's 0.125. At least one.
Okay, find the probability